Hello, my name is Joan O'Callaghan and I will guide you through this lecture on fundamentals of transmitters and receivers. We will start by making an overview of a general diagram of a transmitter and receiver. And we will also see the fundamentals on how transmitters and receivers perform the up and down conversion frequencies from a very low frequency to the frequency in which the signals are transmitted through the air. This is a typical block diagram that I will use to make the explanation. In this diagram, I'm not claiming that this is the basic architecture for every receiver or transmitter system. My only claim is that this is general enough to explain the basic principles of most transmitters and receivers. For example, there are many systems in which we only have a transmitter, or there are systems where we only have a receiver. In this diagram, we have both, and they may act either simultaneously or alternatively. In this basic block diagram, the transmitter chain is on the top and the receiver chain is on the bottom. And these two chains translate frequencies between two different regimes, a low frequency regime and a high frequency regime. In the high frequency regime, the frequencies are such that the signals can be transported through waves in free space. These waves are gathered by the antenna and are directed through cables or waveguides towards the receivers, or the signals come from the transmitter. On the other hand, we have the low frequency regime. In this regime, the signals are slow enough so that they can be processed with electronics, and the frequencies at this regime are maybe a baseband frequency, meaning that the spectrum is centered about zero frequency, or they may be an IF frequency, meaning that the spectrum is centered at a non-zero frequency, meaning that the baseband is translated to that frequency. But in any case, the frequency is low enough for the signal to be processed by the electronics. Now, let's see the essentials of the math that allow the transmitter to do the up conversion. In all transmitters, we have a mixer, which is this element in here, and at the inputs of the mixer, we have two signals entering that mixer. One would be our signal, and the other would be the local oscillator. Now, despite the mixer symbol, mixers are not multipliers. Depending on the hardware of the mixer, the signal at their output, it's at least the multiplication of the local oscillator and the signal, but we might also have other components. But as I say, at least we have the product of the local oscillator and the signal. So for the case in which these two signals are harmonic, what we have is that the product of these two signals can be split in two frequency terms. One which is the LO plus the signal, the frequency of which is the LO plus the signal frequency, and the other term is the LO minus the signal frequency. If we look at the spectrum, then we would have that if the spectrum of our signal here is F sub S, that would be the spectrum of the signal coming into the input of the transmitter. The FLO, the local oscillator frequency, would be much, much higher than this. And then the sum of these two frequencies would come here. So the resulting spectrum of the product of these two frequencies would be something like that. So that's the spectrum that we would have at the output of the mixer, and resulting from the filtering, right? In this case, we would have the spectrum of the signal, which would be upconverted from a low frequency regime to a high frequency regime, and then we could have a power amplifier to drive this, to amplify the signals and drive the antenna or any other stage that we might have after that. Regarding the receiver, in the receiver we would do the opposite function. That would mean we would downconvert the received frequencies to a lower frequency in which we can process the signal. And the mathematics are very similar. In this case, we would have an RF frequency coming from the antenna that would have been, this frequency might have been amplified by a low noise amplifier. And then we would essentially multiply this signal by the signal produced by a local oscillator. And again, we would have the product of two signals of different frequencies, and the same trigonometric identity would apply. We would have then a term with the difference of both frequencies and another term with the sum of these two frequencies. Then with proper filtering, we would only retain this frequency term. Note, however, that in this identity we have a cosine, so it's in principle it would make no difference whether this is a positive or a negative term, and we will see that this have some consequences that I will discuss next. So summarizing, in the receiver we also have maybe some filters and some amplifiers, but we will also have a local oscillator multiplying or beating with the incoming RF frequency, and this is what causes the frequency to be converted to a lower frequency regime, be either baseband or an intermediate frequency. Now, as you recall from the previous slide, I said that the trigonometric identity that we were using is this one over here, and that we were using this term. This is the term that we are retaining in the filtering in our receiver. And you remember that I mentioned that this cosine, the argument of this cosine may be positive or negative. That means that this frequency can, that means that we have two options for placing the local oscillator with respect to the RF. If we place the local oscillator below the RF, then the resulting spectrum is this one over here. We would have an IF frequency, which would be a low frequency, and the spectrum would have no spectral inversion. This situation is called the lower side injection. The opposite scenario is when we place the local oscillator above the RF frequency. In this case, we would have the resulting spectrum would be inverted, and this case is referred to as the upper side injection. These two cases correspond to the two possibilities of having omega RF higher than omega LAO or omega LAO higher than omega RF. And that concludes this first section of the lectures on fundamental of transmitters and receivers.